In this video, let us see how to create shear force and bending moment diagrams for cantilever beam. So we need to calculate the shear forces and bending moments at each and every point, and we need to draw the diagrams. Here this is the cantilever beam. In the previous videos we have seen a simply supported beam where the loads will be shared by the two supports uh, appropriately. But here cantilever beam, you can see this is a black color single support, and this is the portion which is hanging. What that means, it is having only one reaction. Whatever the load applied on the cantilever will be carried by this only support. So we no need to calculate reactions here because there is only reaction that is showing the same amount, how much the load is being imposed on it. So let us straight away calculate the shear forces. By definition, for this shear force is the sum of all the forces right or left to the section. So first I will create my section here. So I create my section here at B, and let us uh, calculate shear force and bending moments. So let us see first shear forces. Shear force. Shear forces. Now let us calculate shear force at B. Shear force at B. What is the load being acted on at the point B? So I'm coming from this right to left. Right to left. So here it is 2 kilonewton is being acted by the sign convention. Uh, right upward negative, right downward positive. So here, otherwise I have told you a simple trick to remember that. Whenever it is a shear force, think about gravitational force. Gravitational force always acts downwards. If the force is acting downwards, it is in the way of gravitational force. So take it as positive. So that's it. It is shear force at B is 2 kilonewton positive because it is towards the earth. It is right straight to the gravitational force. So now let me find out my section here. I'm shifting my section here. So now I have 2 points, two loads. So let us see now. Shear force at C. So I have to calculate, as I am coming from right to left. I need to find out the sum of all the forces on the right of the section I have drawn it here. Shear force at C, that is 2 kilonewton plus, and this is acting downward toward gravitational force positive, 5 kilonewton again towards gravitational force, that is negative. Please remember that is only trick to remember, that is a sign convention, trick to remember that. But otherwise you can simply remember r run, r right upward negative. When the right upward negative, automatically right downward will be positive. Right. Now shear force at D. So now you can now easily calculate. So you have to consider the sum of all the forces up to the section, 2 plus 5 plus 3. So let us see now shear force at D. Shear force at D is 2 plus 5 plus 2 plus 5 plus 3. That is mm, how much? 10 kilonewton. So these are all shear forces we have seen. So let us now draw the shear force diagram first. So here I will draw. This is the reference line. So keeping the points same as before. This is D, C, and this is B. And shear force at B is 2 kilonewton. This is 2 kilonewton. And there is no force between C and B. So let us join them with a straight line. Next, shear force at C. So at C, suddenly 5 kilonewton is being added and it is becoming 7 kilonewton. So, and there is no force between C and D, so the same force will be continued up to D. Again at D, you can see suddenly one force is being added, that is 3 kilonewton. So add it, and there is no force between A and D. So same will be continued up to A. So and finally this. And this is all positive. This is all positive. Positive shear force. So we have done with shear force. Now we shall calculate bending moments. Bending moments. So what is actually bending moment? By definition, for this type of diagrams, so bending moment is generally considered as the uh, sum of moments taken right or left to the section. But as moment is, that is a force multiplied by the perpendicular distance that is causing a movement. It may be clockwise or anti-clockwise. So let us see at B. So bending moment at B. What happens to bending moment at B? So we have the force here and it is acting right at the B. There is no distance, 2 multiplied by 0, that is 0. So there is no bending moment at B. So next, bending moment at C. Bending moment at C, 2. So we have to calculate the force multiplied by perpendicular distance up to the point we are considering. 2 multiplied by the distance up to C. That is 2 into 3.5. That is a moment. Now what is the bending moment actually for cantilever beam? So we need to mention the sign convention here. If you see, this is the cantilever beam and this load up to this point is may cause the beam to bend like this. So it is like crying. So already we have seen the sign conventions, sagging and hogging, right? So it is crying. So it is bending down, it is crying. So it looks like it is crying. Hogging bending moment, that is negative. So it is again a trick to remember. When it is bending downwards, it appears like crying. So negative people will cry. So negative bending moment. And 5 into 0, that is 0. We no need to consider it. But let us see. 5 into 0. So that is how much? Minus 2 into 3.5, that is minus 7 kilonewton meter. Now bending moment at D. Now up to D, how many forces we have? 1, 2, 3, and 3 distances we have. So let us see first. So we are coming from right to left. So 2 multiplied by the distance up to D. That is how much? 2 into 2 into 3 plus 3.5. That is again minus, and 5 into 3. Distance up to D. So minus, again this is also causing a negative bending moment. 5 minus 5 into 3 and minus 3 into, can you guess the distance? There is no distance over there. 3 into 0. So that is 2 into 6.5 minus 15 plus 0. So that is 13 minus 13 minus 15 minus 28 kilonewton meter. Bending moment at A we need to find out. That is the last one. Bending moment at A is 2 into 2 multiplied by distance up to A. That is 2 into distance 3.5, 2. 3.5 plus 3 plus 2, and this is also negative bending moment. This is the force trying to bend the beam like this, which is hogging again, minus 5 into 3 plus 2, distance up to A. So every force multiplied by the distance up to the point we are considering. 3 into 2. This is also negative bending moment. 3 into 2. So that is how much? Minus 2 into 8.5 minus 5 into 5 minus 6. That is minus 17 minus 25 minus 6, that is 3117 minus 48 kilonewton meter. So let us, this is shear force diagram. So let us now draw bending moment diagram. Let us draw bending moment. This here, this is bending moment diagram. Bending again, this is the reference line having points A, B, C, sorry, A, D, C, B, same as before. So what is bending moment at B? This is 0, 0, and bending moment at C minus 7 kilonewton. This is below the reference line, minus 7 kilonewton meter. Bending moment at D minus 28 kilonewton meter, minus 28 kilonewton meter, and this is A minus 48 kilonewton meter, minus 48 kilonewton meter. Actually, no need to mention negative here because it is below the reference line. You can just mention the magnitudes over here. And one more thing here, bending moment is actually load multiplied by the distance. So let me consider load as W into distance as small x. So that is actually moment we are considering, bending moment. So it is just like y is equal to mx, which is actually the straight line equation. It is having a single variable here over here. Y is equal to mx. So this is a straight line equation. So the relation between the points we have mentioned here will be the straight line relationship. So just join all the lines with the straight lines. This is straight line here, sorry. And this is all hogging. So cantilever beam, bending moment it cries, negative bending moment, hogging. This is bending moment diagram. This is how you need to draw it. So in the next video we shall see how to draw the bending moment and shear force diagrams in combination of UDL and point loads. Thanks for watching. Please adjust with the writing over here. It is not very so good. Thank you.